Hello everyone, welcome back to Advent of Code 2024. I'm going to start in a minute on day 5, but for the first time this year I did make some small changes to day 4's solution in between yesterday's recording and this one, so I thought I would show them off. I mean, not in the sense of brag about them, but just like, here they are. Rotations, I renamed transpositions to rotations once, because like the whole thing I was struggling with yesterday was I didn't realize what I needed was rotations. Now that that's actually what I'm doing, I should give it the right name. And I extracted reverse compose with transpose to a little helper function named rotate for clarity. Add a little comment about how diagonals works, because you could imagine it doing a lot of things, but this is what it actually does. Cleaned up search grids a tiny bit, nothing too big either way. Inlined the little lens thing in submatrices, which, since I didn't like the name, why bother giving it a name? And then I spread out the pattern matching for is-xmas over 3 lines so that it's visually clear what it's matching. I guess technically this isn't how Haskell would normally format a list of lists. Haskell uses it's not about the language. The culture around, the conventions are actually to have commas leading a line rather than trailing a line, as you would see in most other languages. I forgot to do it that way today. Doesn't matter. So that's all. Now let's see what's in store for day 5. Day 5, print queue. Satisfied with their search on series, the squadron of scholars suggests subsequently scanning the stationary stacks of subbasement 17. Look at all those S's. That was very rude. I don't know, it's very sibilant. Almost a tongue twister, but not really. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their search of this historically significant facility, an elf operating a very familiar printer beckons you over. The elf... Okay, is this one I actually did? Yeah, 2017 day 1. Very early. What was this about? What? Alright, I don't remember this problem at all. The elf must recognize you because they waste no time explaining that the new sleigh launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your services. Safety protocols clearly indicate that new pages for the safety manuals must be printed in a very specific order. The notation X pipe Y means that if both page number X and page number Y are to be produced as part of an update, page number X must be printed at some point before page number Y. Okay, so this is like a topological sort kind of thing? The elf has for you both the page ordering rules and the pages to produce in each update, your puzzle input, but can't figure out whether each update has the pages in the right order. Each update? What do you mean each update? What updates? Okay, I don't understand what I guess each page is kind of an update and they're all being printed or something. So for example, yep. The first section specifies the page ordering rules, 1 per line, sure. The first rule, yeah, I know what that means. The second section specifies the page numbers of each update. Okay, so a page number isn't an update, but rather it's like a print job, a batch job where you print X pages, and that's like an update. Because most safety manuals are different, the pages needed in the updates are different too. Yeah. So this is an update consisting of printing 5 pages, and then we consult the rules to see how to print those 5 pages. Got it. To get the printers going as soon as possible, start by identifying which updates are already in the right order. The elves need to know the middle number of each update being printed. Okay. So this is how they... Problems like this, they don't generally ask you... I mean, problems in... Like, there's... By framing the puzzle in a way that you only get to provide as an answer a single number, Eric has to be careful in, like, what he asks you. He can't just ask, like, hey, how many of the pages were valid? Or how many of the updates were in the right order? Because, like, you could binary search the answer or just, like, guess it with a sort of within a semi-reasonable amount of time, and that's not interesting. And if you guess it right, it doesn't prove that you, like, did the right thing. So he finds some way to combine all the information that you should have gotten if you solved the problem correctly into a single number, and then that's the answer he asks of you. So in this case, you know, each update that got printed is folded up into, I suppose, the sum. Determine which ones are correct, add up the middle pages, yeah. Fine. So they're asking me well, I was going to say something that isn't true. I was going to say we have enough information, and, like, arguably, okay, maybe we do, but the print rules or the ordering rules are in principle probably enough to order any list. And so what we could do is, after ingesting the print rules and figuring out what order stuff should go in, we could take each update, determine the order it should be printed in by just, like, sorting it in the right order, and then and then just say, is that the same order we received it in? I imagine that's what part 2 will be. It'll be like, okay, now you understand, like, part 1 is demonstrate that you can parse all of this and can tell, you know, whether a thing is printed. Use the rules in a simple way. Part 2 is going to be use the rules in a slightly more complicated way, where you actually have to determine the order for each update. And I was thinking, well, we have enough information. Why don't we just, like, turn this into a sort function and then call sort, or into a comparison function, let's say, and then call sort on the list. But of course, this isn't really enough information. Because sort, typically, for sorting a list, or array, or what have you, assumes that you can compare any two elements and know which goes before the other. And I'm sure there will be some pairs of pages where the sorting rules here don't actually specify what order the two of them should be in relative to each other. But we can't just have our comparison function say, oh, they're equal. Because there might be some other rule that says, like, you know, if I'm comparing 1 and 2, there might be nothing constraining how 1 and 2 compare to each other, but there might be something saying, well, you know, 2 has to come before 3, and 3 has to come before 1, so actually 2 does have to come before 1. That kind of thing, right? I don't know. Like, that you could figure out from transitivity here, right? But I'm still not totally convinced that that would be sufficient. So I don't know about just using sort. I mean, we could do some research on topological sorts, because I feel like that's what this is. Right? this input is specifying a tree, presumably, or a forest of trees. And we want to topological sort something according to that, sort of, I think. Let's go look up what a topological sort is and make sure I understand what I'm doing here. A topological sort, please. Topological sorting on Wikipedia. Dependency resolution. Yes, that's also what this is. A directed graph, linear ordering of its vertices. See, that's true. So every directed edge from U comes before V. Yeah. I mean, you can think of the... I forget what they're called. The something rules. Page ordering rules. As I said, as a tree, right? Where, this here that comes first is a parent of this in that tree. And probably there will be some... Well, is it a tree or is it a graph? As long as it's acyclic, I think it could be a graph, right? Where you have two different things, like A has to come before B, and also C has to come before B, but like A and C are not themselves related. The order of those two with respect to each other is unspecified. I think that would be fine. A directed graph. So that's what we have here. And so there may be there will be some number, probably more than one, of nodes that don't have anything that can go anywhere. They don't depend on... They're never listed on the right side of a rule, meaning they can be first if they want. And we'll have to create... We would, if we were going to do a topological sort anyway, we would have to create a... kind of virtual root node. Well, no, because it doesn't have to be it can just be a graph, right? We don't even need a virtual root node because it doesn't have to be a tree. It's a graph, so this makes sense. Yeah, no directed cycles, right? Which we won't have. And so if we had the topological sort, we could build the graph of page order rules and then sort it using a topological sort into a linear list of... Oh, well, that doesn't... That's too specific. Right? Because there are multiple valid topological sorts, and just because these pages don't happen to be printed in the order that a specific topological sort would give them, doesn't mean they're printed in a wrong order. Right. So I don't actually want to topological sort this, but it's a related problem. If I have like A comes before B and B comes before C, I actually don't necessarily have that A comes before C, do I? That's only true if B is actually being printed in this print run. If B isn't being printed, then it's perfectly fine for A to come after C because there's no constraint directly linking the two of them together. I see. So, to be clear, we could do part one. We could parse this into a list of rules, and then parse this into a list of updates. For each update, just look through every single rule and see if any of them are invalid, are being broken, right? But I want to understand better, like, because it's pretty obvious what part 2 is going to be, right? It's going to be like, for all the ones that are ordered wrong, order them correct, and then like tell me something about them. Or tell me which ones can't possibly be printed because the rules make it put a cycle in or something. I don't know. And for that, we have to understand more than just... Like, if I found, oh yeah, 47 can't go before 53 because 53 has to go before 47. Like, I don't know how to fix the problem. If I just swap these two, maybe it breaks another rule. Really, ideally what you want is to take these 5 pages, consult the list of page order things to find a legal printing of them, I think. So how would you do that? You would build like a set of the pages that you need to print, and choose one arbitrarily and say, I'd like to print this page. Is that allowed? To determine the answer to that, you consult the print order rules, looking at the right side, and say, look, for all of the constraint, like let's say I want to print page 75 first. I would look at this, and that's the only restriction for 75. So I would say, I want to print 75. Is there anything stopping me? And this would say, well, you have to print 97 first if you're going to print 97. But I'm not. So I can go ahead and just say, yep, 75 is printed. And then I want to print 47. And I look up, okay, here's 47, here's 47. I need to print 75 first. Okay, done that. I need to print 97 first. Not printing 97, so I don't care. Fine, 47 is printed. And eventually, maybe, we would get to one... Well, let's look at an example. One they say is printed illegally, because that would... 75 is correctly first. 47 is correctly second. 61's in the middle. Okay. Second and third updates are in the right order. The fourth update is wrong. You would print 75 before 97. So if we were just trying to validate this, we could do that. But what if we wanted to find a correct printing order for this? We would say, I want to print 75, choosing it arbitrarily because it happens to be first in the list. And we would consult the rules for 75. We would see 97. And say, oh, I actually am trying to print 97. So before I can announce that 75 is printed, I'll have to print 97 as well. And then we'd look over on the right to see, is there anything constraining how 97 can be printed? No. So we would announce, okay, 97 is printed. Now, that was the only restriction on 75, so it can be printed. And then we'd move on here and we'd say, 97. I already printed that one. Great. 47, we would again see, I need to print 75. Done that. 51? Print that whenever you want, apparently. Well, that says 61, excuse me. 47 and 75, we printed both of those. 97, printed that too. 53, printed 97, that's fine. Printed 75, that's fine. Printed 47, that's fine. So I think that's like overall an algorithm for determining a valid printing order is build a set of like pages you haven't printed yet, I think is a good way to think of that. And choose one arbitrarily to try to print next. If you find any dependencies in the rule list on pages you haven't already printed, then recursively try to print that page. And if you ever find yourself in a loop, well, you'll be in for a bad time. I mean, I think we should assume that there won't be any. Maybe part 2 is going to be detect loops or something. Find which ones could never be printed because the page printing orders have a contradiction in them. So maybe what we should do then is, obviously we're going to implement the parsing and build an ordering map, I guess, where you look up as a key the right side, and on the left you get a list of all, or a set, I guess, of all the things it depends on. And then I guess actually you don't want a set. You just want a list of pages to be printed, really, because the order does sort of matter. I don't know. Maybe. So write some function that takes a list of, what do they call these again? An update something? I've forgotten what an update is. Yeah, each update. So reads an update, and it takes as an argument a function to handle wrong dependency order. And in part 1, the function will be like, return false, don't do anything. And in part 2, it'll be like, do the print the dependent pages next, or something. I don't know. Let's get started on the part we were always going to have to do, which is building the parsing stuff, building the data structures. And maybe we will just do like the obvious thing for part 1, and then once we understand what part 2 is, we'll implement that. So import data map strict. I always forget how it's like import. I hate the order of the keywords. And import qualified data map strict as M. Import qualified data set as S. I think we'll need both. There's not a set strict and a set lazy. Are there? Data set? Because unlike maps, you kind of need yeah. there's a lazy map and a strict map because you can be lazy or strict in the values of the map. The keys you kind of have to be strict in because that is needed to build the data structure correctly to allow you to look stuff up. And for sets, like, the values and the keys are the same thing. You can't really have a lazy set. I mean, I'm sure you could, but it wouldn't be the same. It would be radically different from the sets that we have in data set. What does our input look like? Oops, I'm typing the wrong keys. That's why I won't do what I want. So we have a bunch of these things and a bunch of these. So that's fine. We can use text regex applicative here today. Import text applicative. I need regexes. I certainly need matching. I need symbols. I need like a specific symbol. Pipe and new line. And I need comma and new line. I think that's about it. I might end up needing some other applicative operators, but not specifically from text regex applicative. And then, of course, I also need text regex applicative common decimal to parse the ints. So let's define some types. I think it's reasonable to define a data type for like a, shouldn't have closed this tab, I guess, for one of these, even though they will be very short-lived in our program. They'll only exist while parsing. We'll quickly consume these and build a map out of them instead. I mean, maybe I just won't even give that a name because it's just a tuple of two things, but I think it will be kind of nice to give it a name so that because it's kind of weird, like if you're building a tuple, you're going to parse these two things, but you want to put this one as the key, which means it goes on the left, and it's just a little weird if you build a tuple, you flip the tuple operator. You could totally do it, and it would be more concise, but I hope it will be more readable to do it this way. So let's say data dependency, a dependency of, let's say it takes a before and an after, which are both ints. I don't expect we'll need to show any of these, but like, why not? And here I've put before first, so that we can just use this function when we're parsing. We'll give it 2 ints, and they'll be in the right order. That is, let me just super double check. The first rule, if an update includes 47 and 53, 47 must be printed first. Yes, okay. So the one on the left is first. Most of the other stuff we'll need is just type aliases for existing types, right? So like type rule ordering is a map, an m.map from, well, you know what? Type page num. Type page, why not? That's an int. So these are not ints, they're pages. This is a map from page to set of page. So when you look up what has to come before page P, you get a set of things saying these all must come before P. Or perhaps you get nothing because P doesn't depend on anything. And let's then say type update is just a list of page. Because that's what we'll be parsing. Should it be a list? It wouldn't be so bad if it were a sequence, right? Or a vector? Actually, what does Haskell think? Like, what is the Haskell? There's like a vector library. Are those fixed size or? I don't know. I think a list is probably fine. It's a little awkward because we can't so easily get the middle element of a list. And that's like the main reason I think a sequence would be kind of nice, is they're random accessible. But, I mean, like, look at these. N is like, I don't know, 68 over 3. There's like 20 elements in the list. It's not expensive to do indexing on these lists. So I think that we will just use a list and do indexing. Call length, look up the middle element by indexing. You're traversing the list 3 times instead of 1 time. Disaster. But like, who cares, right? That cost will be swamped by everything else we're doing. So I think that's fine, a list of page. So then we'll need a data structure for our inputs. Data input is an input of rule ordering and a list of update. That's what we'll parse in our prepare function with a regex. I usually end up needing from maybe, don't I? Is my recollection whenever we're parsing stuff. Here's a question. There was some previous day where I used regex applicative, right? I don't remember which one. Which day was it? Day 5 we've just done. It was day 3. Okay. So in day 3, I don't remember having like what I did with the maybes. So when I parsed this, prepare, I just gave I called identity. Ah, right. Because I wasn't parsing the whole input. I was scanning it for specific things. And so there was no question of like, oh, it either matches or it doesn't match. I found a number of matches, and then I like looped over them or folded over them or something. That's why I didn't have to deal with the fact that a parse can fail. Right. So I think that is like, I usually ended up needing from maybe is my recollection. And that's not in Prelude these days, is it? No, maybe is. Maybe I could just use that and stop putting this import in my files. We'll see. Or, of course, you could pattern match. There's a million things you could do. So we need a parser for inputs. But that's, well, I mean, why not? Let's just start from the top down. Input is an RE from char to input. Input is Let's use applicative do today. I'm sure I'll want it at least a little bit. Maybe it's already implied? I don't know. So let's say input is, I don't know, we don't really need, maybe I don't need it at all. Let's just get practice writing stuff in applicative style, which I have that practice. I can do this. I gave myself a little thumbs up. You couldn't see it, but we're being chipper and positive here. So input is to call input on the result of parsing first a rule ordering, then a single blank line. Is that correct? So because each rule ordering ends with one new line, then we'll read one more new line and then start reading the updates. Yeah. So that'll be our rule ordering, and then many update. Many is in prelude now, right? No, it's in, okay, fine. I guess P comes before R. Many. There you go. Or is that? Yeah, it should be applicative. Where? And look, it's, we're done. We wrote the input parser. Very simple. Of course, we still have more writing to do. But a rule ordering is m dot from list with combined sets with, well, that's m append, right? To combine two monoids. So we'll be building a set of the things. From list with blah map dependency. I guess we had a name for that. And map all of this over many close to KV. A dependency is to call dependency mapped over decimal, ignore a pipe, and then a decimal ignoring a new line. I think that makes sense. 2kv needs to take a dependency. Dependency before after is a single tuple where after is the key and the value is singleton of before. That looks right. An update is is there a good what? Parsing a, let's see. Like I want sep by but for applicatives. Does sep by, okay, somebody, Attoparsec has it. for alternative. Yeah, I guess it's for alternative, actually. Text parser combinate, like... A million people have implemented sepby in a bunch of different libraries here. Sorry, you can look. And they all have slightly different types. But none of them are actually in... There's one that's in base, I just found. But it's specific to text parser combinator's readp, which I'm not using. Why couldn't it just use applicatives? I guess I'm going to write my own again. Yeah, and here's the other one in base for parser combinator's readp. All right. Whatever. But update is just decimal sepby, comma. So what do I have left to implement? It's just sepby? That's not so bad. Sepby, provided that f is an alternative, it takes an FA and an F. Oops, what am I doing with commas? FA, FB, and produces an F of list of A? That sounds right. Is there some reason I would need sepby1? What's the difference in here exactly? The difference is that it always has to match at least one of them, I guess. Yeah, one or more occurrences, but 0 or more is fine. So we would say sepby p sep is well, I guess I'll actually say that I do require there's at least one, because there shouldn't be any blank lines. So it's to parse P. It's to... I can't quite remember. Like, I want a cons... Yeah. I want to map cons over P, and then many ignore sep parse P. Right? That's all sepby is? Well, this is sepby1. I guess I'll name it that way for clarity, because that is sort of established that sepby can handle 0, and I don't want to do that. So does this, would you say this compiles at all? Really? Nope. Am I in the wrong place? I'm still in day 4. I thought I went to day 5. Rule ordering is what I called it. And I need control alternative? Where is alternative? Oh, it's in control applicative. There we go. So, of course, lines doesn't compile because it's wrong, but... Oh, and yeah, okay, yeah, missed something else as well. I needed another operator here. There we go. So now the only issue is that lines is the wrong type. This stuff all compiles, which is very nice. So what would happen if I were to say, test this? I haven't written prepare. There's one thing I forgot, actually. We need to consume the new line at the end of an update. That looks fine. So let's test a few really simple Prepare is undefined. There you go. That'll type check. So what if I said... Oh, and of course all of these... I was gonna test rule ordering and test dependency and so on, but they're all hidden internal definitions, and so they're not exposed. Okay, well maybe I can just test input. Let's match input to 1234. New line. Just match one rule, I guess. New line. 3, 4, 5. New line. Forgot. But, okay, so that could match expected type. Oh, it takes its arguments in the other order. I always forget this. No instance for show input. Well, you got me there. I do want that. And that's a reason I would have wanted show on dependency, so how nice that I already put it there. Yeah, that's an input saying that 34 depends only on 12, and we want to print 3, 4, and 5. So let's enrich this a little bit to say that also, 55 is depended on by 34, and we also want to print 2. I need to put another new line here. Yeah, 34 depends on 12 and 55. Perfect. Okay. So once I got things type checking, the parser was correct. That's nice. You know what? I could just commit this, couldn't I? It's a nice little incremental step in the right direction. But it would be kind of nice to do prepare first. So what if prepare were maybe... What do I want to do if I get nothing? Just error or something. Error, no parse. Identity. Composed with matching input. That seems right. So now if I said we actually are just returning an input, would it parse the whole thing for me here if I wrote main? Yeah. So it's found all the inputs, or all the updates, and it's got a list. It says, oh, 11 depends on a million things. So does 13. So does 15. Wow. Oh, so does 12. I missed it. It's over on the right there. Okay. So great. This looks like we have the parser well in hand. Sure. Let's commit that. Git add. Yes, I want all that. I want this. I typed U. Whoops. Yeah, this is basically just like the whole file. Sure, commit that too. Day 5. Parser, not the parter. I'm so used to typing comma part that my fingers took hold of me there. Yeah, I mean, I'm happy with this. I think this is an example, as I always like to go on and on about how it's an example of how parser combinator libraries and regex combinator libraries in this case let you write more composable and hopefully maintainable parsers than just like chucking a bunch of regexes at it. I'm sure you would probably use fewer characters if you just like wrote a regex. Like a regex to handle a rule ordering and a regex to handle an input are both like extremely simple. And like you could write a little function that like parsed one until it failed to parse, and then parse the other, and like, maybe it wouldn't be fewer characters, but it's just really nice that it all type checks, it is actually you can't get something out of this that I don't know. It's just really nice, and it's easy to reuse common code. It to produce the types that you actually want and not just a bunch of scattered strings that you have to convert. I'm just very happy about that in general. I think you actually technically don't need the parentheses here, at least. I'm sure there are many places where I have parentheses in I don't need, and I just don't. That's because I don't know the precedence of some of these operators. But this one I'm pretty sure I could get rid of, but I don't have to, so I won't. Oh, another thing that I had forgotten about that I knew like in previous years that I had forgotten, and this year it was kind of bothering me, is that with text regex applicative, let's go look at its documentation, actually. This will be kind of interesting, maybe. Not very interesting, but a little. There's the documentation, like, okay, you build a regex using a bunch of alternative and applicative operators, and, you know, there's all this fancy stuff you can do, but eventually you end up calling, I must have scrolled past it, match. Yeah. You call match. And I was struck by the fact that there isn't a compile function. Match implicitly compiles when you call it, and that's fine if you're only using a regex once, but it's kind of expensive to compile a regex. You know, wouldn't you want to save that in between calls? And there just isn't a function to let you compile and capture the compiled regex and do something with it. For example, call match on it multiple times. And the cute trick here is partial application is all you need. If you call match and pass it just a regex, of course you get back a function that wants an input string, but that function has pre-compiled the regex for you. So if you call match on a regex and save the function that returns, you will only compile the regex once. Now I think you can't actually get the advantage flip match. Does this make sense? What happens if you call equal tilde and pass it only the second operator? Flip match. I think if you use this operator, you actually can't precompile the regex. I'm not 100% sure operationally how this stuff works, but I think that's true. So if you actually want to use a regex multiple times and you care about performance, I guess you should call match. So maybe I should get in the habit of that. And here, you know, it's really simple. Match input. Still is correct? Yes, okay. So we'll just amend that change in. And we'll get to part one, I suppose. Let's see. We're supposed to calculate the ones that are correct or aren't. The middle page number from correctly ordered updates. So I actually want to return int here is some map middle page filter valid update of, oh, I guess our input needs okay, I guess we'll just pattern match on it. Input of ordering updates. Filter valid of updates. Where middle page of x's is x's looking up length x's over div 2. So if we have like 3 elements, we want to look up the 1th element, right? We have 5, we want to look up the 2th element. So div 2 is just correct. No need to add 1 to it. Okay. So we actually really did not need these parentheses. And then we just have valid to work with. Valid pages equals something. I suppose I want to go... No? Yeah, maybe go pages and from list pages. Here's the set of things still pending to print. Or, yeah, like here's the order we've chosen to print things. And here's all the things we have not yet printed. Well, I guess this is fine. Where go of empty anything is true. It was valid because we printed all the pages without first finding a problem. Go of PPs and pending. The thing is, like, pending is always just going to be the set of P's. Like, I don't even know why this is really here. If it were really inefficient, like, what's going to happen? I'm going to say, I want to print P. Is that allowed? And then I'll say, does the list of pending pages intersect at all, have a non-empty intersection with the list of things that P depends on? And then I'll like delete one item from the pages. It just seems silly. Let's just not do that. So let's just say valid of empty is true. Valid of EPs is something. We don't need this go function. If any is slm, is that the name of the function I'm looking for? I have data set open already. lm. Oh, it's called member, maybe? Member? Yes, okay. smember takes its arguments. It wants the key, and then... Oh, annoying. Okay. So, smember of m dot find with default. What order does that take its stupid arguments in? Find with default. It wants the default first. Same empty, the empty set. Then it wants the key and then the map. Okay. So P is the key. and the map is ordering P's. Actually, we can say, yeah. If any of these are in the list of things it depends on, then false. Well, is there something that's like any but inverted, not all? None? All, not? I mean, I want to say... God, I've been here an hour already because I was thinking about topological sorts for so long. Well, whatever. We'll just... It's false. And otherwise... This doesn't... It feels like it belongs over here, even though it's kind of a long line. Otherwise is valid P's. There's a better way to write this as like... You require that not any of these are a member, and then also that P's are valid. So, does this type check at all? It does. Does it run? It does. It's a number. 5588. I mean, that sounds plausible. If I said... Well, I don't actually know how many updates... I guess Emacs would be the one to ask, right? How many of these are there? There are... We start at line 1178. So around 200 of these. And, you know, the numbers range from 0 to 100. So on average, they should be about 50, right? So 200... times 50 would be about 10,000 if all of them were valid. So this suggests about half of them were valid. Yeah, 5588 is a very plausible number indeed. So let's copy that and see if the website likes it. That's the right answer. All right. Let's get that committed then. Day 5, part 1. So overall, like this is a very simple algorithm, right? And the data structures are not exactly complicated either. And the parsing isn't complicated. Like none of the pieces of this have been difficult. I was just thinking about a better way to do it. I don't like the way that part 1 just handles the pages one at a time and just checks that it's valid, because I wish I knew what part 2 was going to do and could just do that first, but I guess that's not the way to think about things. Part 2. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each of the incorrectly ordered updates, use the page ordering rules to order them correctly. Yep. Then take only the incorrectly ordered numbered ones, order them correctly, and get their middle page. So I guess what this is telling me is that every page, every update, has exactly one correct ordering according to their rules. Which is a bit of a surprise. The rules must be very... maybe very comprehensive, or maybe the list of updates is carefully tailored to the rules. Because you could imagine, you know, a lot of these, there could be multiple valid printing orders, but apparently not. They all have exactly one valid printing order. Okay. So... yeah, then we can do the algorithm I described before we started this whole actually implementing stuff of how you would go about finding a correct printing order. And it turns out there is only one. So if we had done this first, we could have just said, hey, compute the correct printing order. Is it the same as the printing order we were given? If not, it's invalid. But, okay, we didn't know that. And I think it would have been foolish to try that, even though it happens to work. So what we can do then is say that part 2 turns an int. Part 2 of input ordering updates is some map. Well, we don't just have a map and a filter, really. I guess what we have is kind of a bind. Map, maybe? That makes sense. Because we want to bind something that returns 1 or 0 elements, and that's obviously just a maybe. So map maybe of reorder. Map middle page. Map maybe reorder updates, like so. And we'll just have middle page belongs up here. And I guess it really should be, I don't know. It's more general. It doesn't depend on being an actual page, but honestly, it is a partial function. If you gave it an empty list, it would explode. Like, you look at this type signature, and it's obviously wrong. There's no functions of this type exist that are total. And having to write it out that way, I suddenly feel a little bit bad about it. But I'll stick with it for now. Where reorder of pages. I think here we do want go of equals go of pages and s from list pages. We want the set of pending pages. Because we might well, wait a minute. Do I even need pages at all? Why don't I just use the set of pending pages? Yeah, I'm removing items arbitrarily, of course. And I do need, well, I need the original pages around so I can compare it to the order I eventually settle on. Which is fine. Go will have pages in scope. But it's actually not so easy to accumulate things in the right order here, I feel like. Because if I choose arbitrarily an item from the set, and I try to print it, if I find that it has a dependency on anything we haven't yet printed, well, I was going to say that I should like recursively print that page, and then when that's done, come back to this one and print it. But I guess I don't have to. There will always be some element. I don't have to remember which one I was in the middle of printing when I resolve a dependency. I can just throw away the fact that I was trying to print something and instead go print the thing it depends on, right? Eventually, I'll find one that doesn't depend on any of the not yet printed pages, and I'll print it. And then I can just go back and choose one arbitrarily. Sure. Okay. So maybe I can just get away with doing it like this. Go of Q. Gotta call it a print Q. If well, reorder. If go of from list pages, let's not call it go, maybe is the problem. Correct order of from list pages equal, if pages is equal to the correct order, then we return nothing. If pages are in the correct order, return nothing. Otherwise, return just correct order, where correct order is go of this. Maybe this is a structure that makes more sense. So we have a function called go that computes the correct order for a set of pages. Reorder checks whether the correct order is equal to pages, the original order, and if so, it doesn't return anything. If it was wrong, it returns the correct order. This makes sense to me. Okay. Go of Q where S null of Q is nothing. There's nothing left to print, so return an empty thing. Actually, is there like a view pattern for sets? Can I have? Does that exist? This is data int map. Query? No. Maybe under min-max? So like, we could use max view to choose something arbitrarily. Or min view. Like that's one way to choose one arbitrarily. It's kind of weird to me that there isn't actually a convenient way to just like choose the root element, please, or whatever. I guess I don't even know which one is most convenient for it to remove. Yeah, none of this really matters to me. Okay. So I think this actually isn't quite right, because Go needs to know what page it's trying to print. So that I can recursively call Go trying to print a different page, right? So maybe I should just call max view. No. Because I want to arbitrarily choose something from the set, but not remove it. I mean, right? Maybe. Okay. Case s dot min view, I guess, or max view. They're basically the same. Min view. So maybe Go won't be recursive. Go will say traverse the dependency ordering until you find one that doesn't depend on anything not yet printed. Case s min view of q of nothing. The set was empty. We're done. If it finds you a page maybe I don't even want to call min view. Maybe I just want to call like lookup min, find me the smallest item. Because I don't actually want to remove the page from the list of pending things. Yeah, let's try this. Lookup min q. Yeah, so if there's nothing here, we're done. If there's something, then look up P in the ordering. Let's do that. Let deps equal. Oh, you know what? This. I kind of want like this as a helper function, but I guess I'm only using it once. Well, I might use it. You know what? Let's let P prime be greatest ancestor or something like that, or first printable or something. First printable of P. So we can define that little function. And it depends on the queue, so it has to live here. First printable of P is I have to like look up in the dependencies. I have to look up the dependencies of P. And if any of them are not, if I find one that isn't printed yet, that is still pending, then I'll just call first printable on that new one, right? That should be okay. Because it can't circularly depend on the one we have. It might circularly depend, it might depend on one of the other ones we didn't choose. Like A could depend on B and on C, and B could also depend on C. And like I might accidentally pick B instead of C, but I'll be making progress still. Man, this doesn't feel great. I want to let deps equal S intersection? What is it called, do you think? Intersection. Oh, I'm actually looking at the... Oh, that's the one for maps? I want the one for sets. Yeah, intersection takes 2 sets. Okay, great. I want the intersection of the Q and m dot... Actually, is this still in my paste buffer? It is. Intersect the Q with... Yeah, I actually think I just want to say case this of... Well, no. Because I need to do, like... So, okay. I now have a list of all the pages that have to come before P. And if this list is empty, I can just return P. So in case s dot lookup min, I think, again. Lookup min deps of nothing P. There's nothing I need to print before this. I can print P itself. And it's just... some other page, a dep, call first printable of dep, right? I think that makes sense. So now we've found the first printable page starting from some... We found a printable page based on choosing arbitrarily one item from the set and finding its furthest away ancestor. And I think it's just in P prime cons to go of s dot s dot delete P prime? I think delete is like, it's partial, of course. Actually, maybe it's not. Maybe if it's not there, it just returns the original set. Go. Yeah. Here, we can even look at the source. Delete says, it calls go and like whatever, blah, blah, blah. But eventually it says, if I match an empty set, the item I was looking for was not in the set, I don't return an error, I just return an empty set. So, and of course, you know, it's an empty subset. So we will delete only, yeah, okay, this seems fine. So p prime cons to go of delete p. This seems plausible. It might compile, and if it compiled, it might work. What do you think, GHC? Not impressed. Map maybe isn't in scope. Sure. What else? From list is applied to too many arguments. Okay, it's inferred the wrong type for pages somehow, I think. My reorder function is wrong. Yeah, so like here, it thought it would find a function from set of page to set of page, and it found a set of page. Here, it thought it would find a set of page, and it found a function from set of page to set of page. So something's wrong with how I'm calling something. It would sure be nice if I had some types on some of this stuff, huh? Oh. Wait, no. Correct order. Yeah, we're returning a list. Well, let's see if that is part of the problem. I imagine not. No. So what type do I think Go should have? Go should be from a set of page to a listed page. Aha, that's much better. Now there's only one error. Delete is applied to too few arguments. You are so right. Okay. So we had to, it inferred a type for Go that was wrong, or well, that was correct based on the source of Go, but not how I was using Go. So we have to say, what? Delete takes the key and then the set. Okay, so it should just be key. Okay, great. So that was all it needed. I'll leave the type in here because I think it is sort of useful. Run it. A number very similar to the first one. I mean, if we had about half of them correct before, this is about half of them still. Those are the ones we fixed. It seems plausible. Great. Okay. So I want to commit this, but I do want to look back over it and see if it could have been done a little bit more cleanly. Day 5, part 2. Because all these case blah of nothing, like both of these are sort of, I mean, I don't know. This one, we are using p prime twice, so it makes sense to let it. But this one is very simple. It could just be like we could use the maybe combinator and say in maybe p first printable applied to this, right? Yeah, that's still correct. Now, is that better? I don't know. It's shorter. I think it is just clearer to write it the original way, right? Like, I have some experience. I'm a little bit used to, but not like super duper used to using maybe. I'm a little bit more point free than like you should be, I think. And so I tend to use maybe where like pattern matching would be better, really, more readable. But this just, I don't know. It doesn't look super clear here. I think I like it better the original way. So that is no changes, right? Yeah, okay. And the overall algorithm, I think, is about... It seems fine. You map maybe reorder. Of course, that all is correct, and you can't really make it any better. The question is just the implementation of reorder and correct order. We call... we work on just a set of pages. It's this like constant looking up mins that I just don't exactly like. Like, I don't know. This all goes back to my idea at the beginning. Like, wouldn't it be nice if you could just call sort and have it work? Because that is what we actually ended up doing here, right? We were given... No, it isn't. Because, well... We have this kind of virtual graph of like the ordering rules, right? But only a subset of that graph applies to each of the print jobs because only some of the pages are actually being printed. So maybe it would have been interesting to, like, instead of using the print rule ordering rule as given and then processing the pages we have, what if once we get a set of pages, we first delete all of the print rules from the list of rules that don't involve the pages we're printing? On either the left or the right. So like we delete all the keys that aren't one of the pages we're printing. And in the values, we delete every element, every dependency that isn't one of the pages we're printing. Then we could just do a topological sort, right? Because, well, no, we couldn't. Because if, let's say they asked us to print pages 1, 2, 3, 4, and 5, and there weren't any rules involving 1, 2, 3, 4, or 5. We would say, oh, well, okay, I'll topological sort your empty list of dependencies. There's no items, have fun. So we would have to be a little bit more careful to make sure... I guess we would merge in node. We would create a node for one saying it has no dependencies. Please merge this with its existing dependencies. And then we could do a topological sort. That's an interesting idea. Let's go look back at the Wikipedia article for topological sorting here. So here's, yeah, I understand. There are many valid topological sorts. Scheduling things based on dependencies, running time linear, and the number of nodes plus the number of edges. Fine. So it's been a long time since I've written one of these. L is a list that'll contain sorted elements. Set of all nodes with no incoming edge? What do you mean by incoming? Which direction is incoming? So 5 depends on 11 here, right? Yeah. No, 11 depends on 5? An edge from U to V means you have to print U first. Okay. So 11 depends on 5. So the source node has to go first. So anything with no incoming edges find a list of star nodes that have no incoming edges and insert them into a set S. While there's at least one item here, remove a node and put it in the output list. For each node that depended on it, remove that edge from the graph, and if that has made the other node now have no other dependencies, put it in the set of things you can do next. Sure. So this doesn't really look any easier than what we did. The advantage it has is that probably somewhere in Hackage, someone's implemented topological sort. And if we could just frame our problem as a topological sort, we could just take the answer. So let's look, what does that look like? If I look on Haskell, on Hugel, for topological, does that help at all? Topological order, there's a thing in Cabal, there's a thing in GHC. Topo? There's something called Kryptonite, and something in GTK. Oh, now I'm seeing stuff like 2 polynomial because I searched for topo. But there's a graphs. Actually, does containers have graph algorithms in it? I don't use those very often. Data containers, data graph. It has, well, yeah, graph. Is that? I don't think that's what I want. Utils, internal, no. Graph algorithms? Aha. So, I mean, I don't think I'm going to do this today, but if we could turn our problem into a topological sort, we could just call topsort from data graph, which is in containers, which is the library that uses maps. We're using the maps from containers, so we do have data graph without even adding a new dependency. So what is a graph? It's an adjacency list representation of a finite directed graph. It's an array? What is an array in this context? Okay, it really is a data array, okay. What do you mean, array of indexed by vertex? Okay, what the hell is a vertex? It's an int. Really? This is not, I wouldn't expect this to be the representation of a graph in Haskell. You have to turn things into ints. I think I remember that someone made a wrapper, was it Sandy McGuire maybe? Probably not. who wrapped data graph in something that like is a little bit less primitive oriented. So a graph would be an array from int, an array of ints. An array indexed by int where the values are list of int. And that's fine, that's what we have. We have it stored as a map with sets, but it could be an array of lists instead. That would be fine. So if we pruned our graph, we could turn it into, if we pruned our map, we could turn it into a graph pretty easily. And then we could call topsort. Well, I might do that overnight and then show it off tomorrow. Just see if it ends up being easier to understand. It probably would. But I'll also look around for if there was, because I thought someone had written a wrapping around this where you don't have to use ints all the time. I happen to have ints this time, but in general I might not. Anyway, I guess that's all for today. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.